So good day everyone. I'm here to discuss about groundwater and its relationship to civil engineering. So basically as a child, you experience playing on a water pump. When you push down the lever of the water pump, water comes through it magically. And that involves the groundwater below the surface. So what is groundwater? So groundwater is a what called aquifers. An aquifer is a geological formation or a part of it consisting of permeable material capable of storing yield significant quantities of water. Aquifers can consist of different materials, unconsolidated sands and gravel, permeable sedimentary rocks such as sandstone or limestone, and fractured volcanic and crystalline rocks, and etc. So, what is an aquifer? Aquifer in hydrology is a rock layer that contains water and releases it in appreciable amount. The rock contains water-filled pore spaces, and when the spaces are connected and water is able to flow through the matrix of the rock, and an aquifer may also called water-bearing stratum or lens or a zone. So basically, an aquifer is what we call a tank below the ground surface that can store water through the help of the permeable materials like sand, water, and below it is an impermeable materials like rocks that water cannot pass through it. So when we say permeable, is that a material can allows water to flow through it. So basically, different materials has different permeability rate. So there are two types of aquifers. So first is a confined aquifer and unconfined aquifer. So when we say confined aquifer, are sandwiched or bounded above and below by impermeable beds or by beds of very low permeability, confining layers. Water does not enter these aquifers as easily as they for unconfined aquifers. So when we say confined aquifers is that it's a layer of aquifer that is below to the ground with sandwich confining layers with very low permeability, so water cannot seeps through it very easily. So very low permeability is like it's go beyond deeper on the ground. Unlike unconfined aquifer is an aquifer that is connected to the surface at atmospheric pressure, and thus the upper surface can rise and fall. Water flows through the surface and downward through small surface and fractures to fill gaps between rocks and sediments. So when you say unconfined aquifer is that it can be in the lower or upper layer of the ground surface. So it can be accessibly dig through easily compared to confined layers which has a very low permeability, and like unconfined has a very high permeability that can water seeps it through easily. So the next slide is that the flow of the groundwater. So groundwater and water table. So first is the surface or the ground surface where water came from rain, flooding, so it can seep through the soil. So first is the porous. After the surface, we have the porous rock soil not saturated with groundwater. So when we say not saturated with groundwater is that the water or groundwater in it has very impurities containing rocks, gravel, sand, and soil. Have you remembered in testing a soil in a lab, you have to consider its weight from with water present and after the oven. So you can determine the soil moisture content of a soil. So a soil also has a water in it depending on the location of the soil you've gotten from. Next is the porous rock saturated with groundwater. In this area, you have to consider less amount of impurities of the groundwater because it has in the lower part of the groundwater. So in creating a water pump, you have to dig or borrow a hole or a pipe down to the ground and then pump it multiple times to get the water or the clear water from the groundwater. And between the porous and the non-saturated and saturated zone, we have the water table. It is the most commonly excavated or reachable part of the groundwater, the water table. And then below all of it is the impermeable rock. Impermeable rock means water cannot pass through it, and it serves as the base of the groundwater. Next slide. And chart slide. This is the distribution of water on Earth. So 97% of water on Earth is ocean water or salt water, and the remaining 3% is categorized into 70% of it is ice caps and glaciers, and 29% of it is groundwater, and the remaining 1% of it is easy accessible water like lakes, rivers, soil moisture, water vapor, and water from living things. So basically, the amount of salt water are very large compared to fresh water, and groundwater has a majority of that fresh water and very useful for us humans in developing our water supply in our places. So the relationship between civil engineering and groundwater. Groundwater represents an important parameter in geotechnical engineering. The groundwater has major influence on material behavior, drain or undrained, and changes in groundwater level can result settlements and damage to building and infrastructure. An artesian pore pressure or excess pore pressure in the ground will of course have major impact on material behavior and stability. So considering water present in our construction site, we have to be careful in digging up, because in construction site we are involved, or most of our works involve excavation, and this excavation could excavate our groundwater or water table that could possibly put excess water on our construction site that would be harmful or damage for the soil, that would affect its stability in holding structural loads, and that is very crucial in building a structure. We must consider that our soil is capable enough in holding our structural load before building or continuing the construction site for effective and safe construction. So construction dewatering is one of the most famous in sucking out excess water from the construction site. So construction dewatering are terms used to describe an action of removing groundwater or surface water from construction site. Normally, the dewatering process is done by pumping or evaporation. So depending on the amount of excess water in the construction site, you have two choices, which one is pumping, which is considered dewatering, and evaporation, or waiting out for the water to go away or evaporate. So while evaporation takes time in getting out the water or excess water in the construction site, while pumping out or sucking out would allow us to clear out excess water very fast and put us into schedule, unlike waiting it out to evaporate. Next slide, please. Why dewatering? So construction dewatering is used on most construction sites due to accumulated water in trenches and excavation, or in places with inadequate slope or high water table. In construction projects, in this water should be removed to keep working as scheduled to provide safe workplace. So considering our places, there are places with high water table. So when excavation occur, you would excavate the water table, then that water table can provide an excess water, and that excess water would be harmful for our workplace. And usually In our workplace, in a construction site, we consider using mechanical things that involves electricity and engines, and when contacted to water, it would be damaged and dangerous. For the recap, so groundwater is found beneath the Earth's surface, in soil pore spaces and rock formation fractures. The flow of groundwater below the surface is a fundamental property that controls the strength and compressibility of the soil, impacting soil's ability to hold up structural loads. So what I'm saying is that groundwater is present everywhere, especially that water can seep throughout and has the material that can create an aquifer below the ground. So you have to look or to study the soil before proceeding to the construction to minimize the error or damage of it. So the engineering team responsible for all the phases of project from the planning and budgeting to final construction needs to be aware of the potential impact of groundwater during design, construction, and after construction so their decision would be effective. So the engineering department who is responsible for the construction should consider those present groundwater to avoid further damage and also to ensure the safety of the construction, because when groundwater is present or water is present, the stability and the ability of the soil to hold constructional loads would be impacted if water is present. So you have to consider it before proceeding to the construction. So that would be all about civil engineering and its relationship to groundwater. Hope you learned something today, and thank you.